Okay, 7.6, similarity transformation. And all this is we've been doing similarity. All we're adding here now is the aspect of what is a dilation. So we've talked about similar. Similar is same shape, different size. A dilation is just taking a shape and either reducing it or enlarging it. Now, the scale factor is the value by which you do that. So if your number is greater than 1, bigger than 1, you're making it bigger. If you multiply by a number that's a fraction between 0 and 1, or a decimal between 0 and 1, then it's a reduction. So we're looking at these to determine whether or not it's an enlargement or reduction, and it says find the scale factor, okay? So these are really not bad at all. The first thing you want to do is just look from A to B. So here's A, here's B. So what happened? Well, it got bigger. So that's easy enough. So we know that's in enlargement. So we just write enlargement here. Okay. But then we have to find the scale factor. Now, here's the easiest way to do the scale factor. You're going to take a value for the triangle that's easy to calculate. So, for example, I'm going to take the altitude or height of the triangle. And the reason I'm using that here is because we're going to use it here in a little bit in future chapters. But the altitude or height is 1, 2, 3 units tall here. Now, in the new one, it's 1, 2, 3, 4, 5, 6. So we went from 3 units high to 6 units high. That means I multiplied by a factor of 2. So our factor is 2. Another way you could have done it, you could have done the base. 1, 2, 3. The base in the other one down here is 1, 2, 3, 4, 5, 6 also. Okay? Let's take the next one. So from A to B, so obviously we got smaller, so that's a reduction. Okay, again, I'm going to take the altitude or height. So I'm going to take A, which is 1, 2, 3, 4, 5, 6, 7, 8. That's 8 high. B is 1, 2, 3, 4. 4. So in this case, to get my scale factor, I do 8 over 4. Sorry, backwards. No, that's right, 8 over 4. But it's a scale factor of 2, but you're reducing by 2. So actually it's 4 over 8 equals 2. So let me state that. In order to get the scale factor, you do new over original. New over original. So let's go back to the previous one, problem number 1. How did I get 2? The new value was 6 over the original, which was 3, and that reduces to 2. Okay, let me do one more. So here's A, here's B. So what happened? We got smaller. So again, that's a reduction. So let's take A, 1, 2, 3, 4, 5. Take B, 1, 2, 3, 4. Okay, so again, let's go back. New over original to get our scale factor. New over original. Okay, what was the new value? 4. What was the original value? 5. That is our scale factor. And it's a reduction because this number is less than 1. Okay, so I need to go back to number 2. 4 over 8 is not 2. It should be 1/2. Sorry, that should be 1/2. So I need to fix that. So again, something less than 1. All right, let's do the last one here. A to B, so we got smaller again, so reduction. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4. So new, which is 4, over the original, which was 8, and that is 1/2. And again, that's a number less than 1, a fraction. Okay, so I hope I didn't confuse you. I know I kind of bounced around a little bit there. All right, let's go back over to the next page. So here it wants us to graph. Okay, so I'm only going to do one of these. You can look at the example, but since I don't have graph paper here, it says graph the original figure in its dilated image, then verify that the dilation is a similarity transformation. Okay, in other words, it's got to be the same shape but in a different size. Okay, so I'm going to do problem number 1. So I'm going to graph A is at -4, 1, 2, 3, 4, -3. So there's the point A. B is at 2, 1, 2, 1, 2, 3, 4, 5, 2, 5. So there's B. C is at 2 and -3. There's C. So if I connect that, that is a triangle. Specifically, it's a right triangle, okay? How do I know it's a right triangle? Because B and C have the same x value. So that's a right triangle here. All right, now let's do the second one. D is at -2, -2. E is at 1, 3. So there's D, E, and then F is at 1, -2. So there's F. So again, I have a right triangle. And this was a reduction, okay? So this is a similar shape. Now, again, one way to do this as far as the scale factor, remember we count 1, 2, 3, 4, 5. So the new was 5. The original was 1, 2, 3, 4, 5, 6, 7, 8. So new over original, that would be our scale factor, which is a fraction that's less than 1. So that makes sense in terms of reduction, which we could see in the picture itself. But this is a similarity transformation. So hopefully these have made sense to you.